Now, let's talk about why we really need Cisco ACI and what is its advantage over other SDN solutions. For those who are new to this channel, welcome. I am your host, name's Dean Armada, and I'm the Cloud and Data Center. Rockstar! And on this channel, we talk about tech careers and certifications, trivia and tutorials in cybersecurity, trivia and tutorials in cloud and data center, and my journey as an IT instructor. So feel free to check out the rest of the channel and consider subscribing. I have here our three-tier hierarchical topology, and this can also be spine and leaf topology. It doesn't matter. So why do we need Cisco ACI? Alright, so let's begin. So the purpose of our data center, why do we have our network devices, our servers, virtualization or storage, and why do we all need to connect them to each other? Okay, why do we need to do all of this configuration? Well, I can't think of any other reason why, aside from to serve applications. So we as user, we don't really care what network device or what storage or what kind of servers this data center or cloud are running. We as a users, what matters to us is we can access those applications, okay, securely and reliably. So what I'm gonna do is I will talk about the evolution of the three data center pillars. Okay, the evolution from provisioning to operation. So provisioning, there you go. So from provisioning to operations, and we're going to start first with the compute. Okay, so I'm gonna use this compute. Now compute, many things have evolved in our server compute environment. So before we have this bare metal servers, and for every physical servers we have to install a dedicated operating system. Okay, now through the years it evolved a lot, especially in the late 90s or the early 2000s. We are now, or we this is the time where we started using a lot of virtualization solution. Okay, the hypervisor base. The best example or the most widely implemented is VMware ESXi. Okay, so virtualization solution. Okay, what else? Using virtualization, we can automate the provisioning using templates, and there are more automation features. Okay, now there are also many other technologies under the compute pillar, not only virtualization. We can also use containers or containerization, okay, and many more actually, such as HCI or the hyperconverged infrastructure. Okay, and let's move to the next one. We have storage. So under storage, it evolved also because before we have the SCSI disk that is residing on every physical servers. Okay, and can you imagine how difficult to manage the storage, the backup, if you're maintaining every single disk in every servers? Now what happened is we can now centralize the management and the configuration of disk using storage arrays such as our Dell EMC, our NetApp storage arrays. Okay, and this may run in many different SAN protocols such as FC, FCOE, and iSCSI. Okay, so it's now centralized, and we also evolved from tape drives to hard disk to flash based. Okay, which improves significantly the speed. Next is the network. Okay, now think about it. Was there any improvement or significant change on how we provision our network devices. Think about it. How do we provision a switch or a router? So first thing that we need to do is we connect it, our laptops or PC via console, so we can access the console management of our network devices. Now, once we access it via console, we configure the management, okay, and the management IP, the default gateway. What else? We enable management protocols such as SSH or Telnet, and then we configure the basic settings, okay, the initial configuration, and we have to do this on every single network devices. We call this box to box deployment. Okay, and if you think about it, this is still what we do now. This is still what we do on most of our network device provisioning. It's the same as what we do decades ago. Not much changes. Now that is provisioning. What about operations? Well, what I have here is a three-tier hierarchical topology, and it doesn't matter if it's lift and spine. What I'm gonna do is I'm gonna add our VMs, okay? In our 3 servers, I'm gonna add VMs. The first VM on server 1, 2, and 3, and then I'm gonna add the second VM and the third VM. All right, so let's say this is the running virtual machines. Everything is good. We have applications running in this virtual machine serving many different clients. Now suddenly your management or your application team says, oh, we have a new application. It's now running in a new server in a new network. So basically this is a new network. I'm gonna add a DVS here, okay, a DVS. There you go. So we have now a new servers. So these are new servers in new network, okay? New servers, new application in a new network. Now, in our DVS, we need to add new VLANs. Again, this is the DVS side, our virtual network. Now, if you are managing the switches, the access switches or the leaf, if we're using leaf and spine, we also need to add new VLANs. So not only on the DVS or the virtual network, also to the top of the rack switches where our servers is directly connected. Now, this is new VLANs. Let's say this is VLAN 30, new network. So you also need to add configuration on our backbone routers, okay? Or in this case, distribution, not backbone routers, distribution switches. Okay, so we need to add or apply new settings for routing. What else? Maybe ACL, maybe policy-based routing, and many more. Okay, there are a lot of things that will affect our configuration if we create new network or new VLANs. Okay, now this is just an example of how we change configuration or how our network configuration is affected every time there is a new application on a new network. Now, it's still not major configuration changes. A more major changes will be if we add more network devices. For example, we add more firewalls or a new firewall, a new load balancer. Okay, there are a lot of things to do when it comes to network configuration changes. Now, again, not too automated compared to the compute or the storage maintenance. In a network configuration, most of the time we do this manually. Now, going back to the purpose of data center, which is we just serve applications. Everything, compute, storage, and even applications has evolved when it comes to configuring and operating it. Now, the next thing that we need to know is how can we improve our applications? Okay, how can we improve it? Well, we are already improving the server side or the compute side and also the storage. How about the network side? Well, there's still a complexity. There's still a complexity because our process is the same process that we were doing way back decades ago. So there's a complexity, and to solve this, I have two proposals. Okay, one is SDN, and the SDN that we've talked about in the previous video is what we called the open source or the open flow SDN. Okay, so we use the open flow solution. Okay, this is again open source. Now, if we think about it, is this a good solution? Think about it. Who uses open flow? Okay, who uses open flow? And to the fact that this is open source, there will be no support at all. You will rely on the community. And SDN open flow, if you think about it, it's good, but it's complicated. Okay, it adds more complexity. Why? Who really knows how to maintain and configure open flow protocol, the open daylight, the flow table, etc. And this requires not only network skills, but also programming skills, not application development programming skills, but up to the kernel level, up to the open source programming networking level, which most Cisco network most Cisco network engineers doesn't have. So I will not recommend this solution. Okay. So what else? Well, we have another SDN solution, and this is what we call SDN virtualization. Okay, virtual. SDN virtualization. This is an SDN solution that requires a lot of virtual components, and I'm talking about NSX. Now, personally, I know NSX, and I'm not a big fan of it. The reason why I'm not a big fan of NSX because you need to configure many things such as NSX manager, controller, and you still need to configure vCenter. Another reason why I'm not a big fan of NSX, you see these components, the hardware components, the switches, whether it's leaves and spine or 3-tier hierarchical topology, NSX doesn't have a visibility on the network devices. So let's say you manage this part, okay, as the SDN virtual solution NSX. Again, many components, the manager, the controller, and even the vCenter Plus. There are also virtual network devices such as vRouter, virtual firewalls, and edge routers, edge firewalls, etc. So there are a lot of virtual components. When you manage all of the virtual components, you still need to manage the physical components, which is again not visible by our NSX solution. Okay, so that will be two different teams, or if not, it will be a little complex to handle by a single team, okay, or a single group. Not only that, NSX or the SDN virtual doesn't have, or at least doesn't support integrating to bare metal servers and non-VMware solutions. Okay, also containerized solutions. Or if they are now supporting those solutions, it will still not be effective. Now, I'm not going to also recommend the SDN virtual. Again, it doesn't have a complete visibility up to the physical network level. And can you imagine if you're doing, or if you have a huge data center environment with 100 switches? That will be very difficult. And NSX, doing all of the virtual work, you still have to do the manual configuration of your physical devices. So this problem here is not solved. Okay, the box-to-box deployment, because again, NSX does only the virtual part. Now, what we have is, guess what? It's Cisco ACI. Now, Cisco ACI, I will give you a little introduction of Cisco ACI. It manages the entire infrastructure, whether it's physical or virtual. We use what we call the application profile. Now, the application profile consists of many components, okay, or what we call configuration objects. Now, we're going to make this an introduction of the components of the application profile. first we have the EPGs, or the endpoint policy group. Okay, now what I'm gonna do is I'm gonna create 3 EPGs, the web EPGs, or the web EPG, and I'm gonna create the app EPG, and I will also add the database EPG. There you go, database EPG. Now, what are EPGs? Well, EPG stands for endpoint group. This is where we group applications. Okay, so meaning the web applications should belong to the web EPG, and the database applications should belong to the DB EPG. So it's more of a security, also adding multiple servers, or excuse me, multiple applications, or the same applications in one container. So basically it's just a grouping. Now we know it's for security purposes, so meaning all web servers in the same EPG can communicate with each other, but they cannot communicate to other applications in a different EPG. For example, web apps cannot communicate to the apps, okay? Or applications cannot communicate to the database applications. Why? Because these 3 applications belong to 3 different EPG. That is why we need to add what we call contracts, okay? So there will be a policy which we call contracts in between EPGs. So contracts connects EPGs and apply policies. What are the policies or the features under contracts? We have filtering features. Okay, filtering is like an ACL where we add multiple permit and deny rules. What else? We can also add SLAs, QoS. What else? Well, there are many features also, such as layer 4 to layer 7 services, where we can add load balancer and firewalls, okay, in between EPGs. So this is what we call the application profile. This is a central configuration that represent the entire infrastructure, or should I say ACI infrastructure. So we do the configure centrally, and it doesn't matter how big is your data center, whether you have a pair of spine and leaf with few servers, or you can have 100 leaves with 8 to 10 spines. It doesn't matter. You are relying to one central management or one central policy, or few policy configured in our controller, which we're going to talk about later. We do all of the configuration and policy, and this is applied to our infrastructure in an application-centric fashion. I know you still have many questions. We are just starting. We're gonna talk about ACI components and ACI fabric in the next videos.